Hey guys, welcome to Unit 11 video review. First question says, describe the 5 parts of the kinetic molecular theory. We actually don't have notes on that because it was the one day of the year that we actually lectured in class, and so there were no video notes over it. But these are 5 things we know are true about gases. 1, the gas particles are very far apart, so they're spread apart. That's number one. One, they're spread apart. Two, they move rapidly, and constantly. So rapid, constant motion. Three is there's no attractive force or repulsive force between gas particles. Four is that they have elastic collisions. So when a gas particle bumps into another gas particle, they don't lose any energy, they just keep on going the same way they were going. Last one is that temperature is directly related to the gas particle's energy. So when energy goes up, when temperature goes up, their energy goes up as well. What is pressure caused by? Essentially, pressure is force. Okay, so it's the force of particles colliding with other things. So pressure would be gas particles colliding against the wall of their container and with themselves. Temperature measures heat energy. And then we have to write the equations for these 4 laws we learned. Boyle's law is the relationship between pressure and volume. So you can draw the equation like this. Charles's law is between volume and temperature. So you can draw his law like this. And Dalton's law is the law of partial pressures, meaning that the total pressure in a system equals the individual pressures of all the gases added together. And then ideal gas law is PV equals nRT. Okay. Boyle's and Charles' law, by the way, we combine them into what's called the combined gas law. The combined gas law looks like this. Okay. All right, so you will need to know how to do conversions. So the next question asks about conversions. How do you convert between Celsius and Kelvin? Well, 0 degrees Kelvin is the same as 273 degrees Celsius. So basically, if you want to get to Kelvin, you just add 273 to get Celsius. So if I have 175 Kelvin, I do subtract 273 to get Celsius, which is negative 98 degrees. And when I'm going Celsius to Kelvin, I'm going to add 273, which gives me 3. STP stands for standard temperature and standard pressure. Standard pressure is 1 atm, and standard temperature is 273 K, or 0 degrees Celsius. Okay, describe the relationship between pressure, temperature, and volume. So when pressure of something increases, let me start with volume. Okay, so when the volume of an object goes down, so here's the volume of a container. When the volume of the container goes down, the gas inside there has more pressure. So when volume goes down, pressure goes up. In the same way when you reverse it, when volume goes up, when we increase the pressure of our system, or increase the volume of our system, then the pressure goes down because there's more space for the gas particles to move around in. When you increase the temperature of a substance, the gas particles move faster, they have more energy, and so they also exert more pressure on their walls. When we lower the temperature, then the gas particles move slower, and so they exert less pressure on their walls. Okay, on the other side of the page, we're actually going to do some problems. So I'm supposed to explain whether these scenarios are explaining Boyle's or Charles's law. So when a balloon pops floating high into the atmosphere, well, in the atmosphere, there's a lot more pressure down at the ground, and then up in the sky, there's less pressure, okay? So as a balloon rises, its pressure is going down. So when pressure goes down, we know volume increases. Because when there's less pressure on the balloon, pushing the balloon in, the balloon will start to expand if there's less pushing on it. So that's why it pops. So that would be considered Boyle's law, because Boyle's law is between pressure and volume. A balloon pops in a hot car. So here's your balloon in the car. As it heats up, the temperature goes up. So when the temperature heats up, volume also increases of the gas particles because they have energy, they have more pressure, they can push on their walls, increasing their size. And so that would be Charles's law because it's a relationship between volume and temperature. Now let's do some problems. Number 9 gives you 4 problems. It wants you to figure out which law you're using, Boyle's, Charles, Dalton's, or ideal, and then to calculate the answer. So first I'm going to write down all of my variables. So I have volume here, pressure. I have another volume. So this is volume 2, that was volume 1. And then it's asking for another pressure. So we're looking for pressure 2, and the one they gave us was pressure 1. So we're using Boyle's law because it's between pressure and volume. This is our formula. P1V1 over T1 equals P2V2 over T2. Now, since temperature wasn't mentioned, we're not going to use it. So our formula now is P1V1 equals P2V2. So P1 was 7.50. V1 was 300 milliliters. P2 we don't know. V2 is 125 milliliters. I'm going to divide both sides by 125 to get P2 by itself. And then my answer is 18 ATMs. When I multiply 7.50 times 300 and divide it by 125. Okay, B. Again, let's label what we have. This is volume, liters. This is temperature. This is temperature again. So this is T2 and this is T1. And this is our new volume, so it's V2 and then that was V1. So here's our formula. P1V1 over T1 equals P2V2 over T2. Now pressure wasn't mentioned at all, so we can cross it out. So it's just V over T equals V over T. So V1 is 50, T1 is 75 degrees Celsius, V2 is 110, and T2 is what we're looking for. Now you don't have to convert Celsius to Kelvin unless the temperature is 0. If the temperature is 0 degrees Celsius, then you need to convert to Kelvin because you can't have 0 in a fraction because it will just ruin the whole thing. So I cross multiply. Well, okay, yeah, I cross multiply and divide. So I'm going to multiply these two. 75 times 110. I'll divide by 50, and I get 492.6 degrees Celsius. Oh, and what formula is that? Well, if it's volume and temperature, this is Charles's law. All right. Now, label. We're looking for volume. We have grams. We have pressure, and we have temperature. So we don't have 2 of anything, so we know we're not using Boyle's and Charles. The only other law we could be using would be PV equals nRT. We have pressure. We're looking for volume. We have T, and R is always a given. So we also have R. R is not given in the problem per se, but R is a constant, meaning it's a number that will never change. It'll always be this number. So the only thing we need to find volume is N. So let's first solve for N. N is moles. So how do we get moles? Well, we have grams. To get to moles, put moles on top. and we want to get out of grams, so we put grams on bottom. Put 1 next to the mole, and you find the mass of helium, which is 4.00, and we divide them, and we get 11.99 moles of helium. So that is our N. So now we can plug in, okay, so pressure is 4. We're looking for volume. Moles is 11.99. R is 0.0821. Temperature we actually have to convert. So whenever you're doing this formula, PV equals inert, your temperature has to be in Kelvin. So we add 273 to that number and we get 325. So how do we solve this? Well, I'm going to first multiply all of these numbers together, okay? And then I can divide both sides by 4. Your final answer should be 79.98 liters. And I know it's going to be liters because whenever you use this formula, V has to be in liters. So that's how I knew that. And our last one, oh wait, what formula is this? The one we just did, that was the ideal gas law. Okay, this last one is going to be Dalton's law. Dalton's law says that the total pressure of a system equals the pressure of your first substance plus the pressure of your second substance, and so on and so forth. Since this only has pressure units, I know we're dealing with Dalton's law. So it says a sample of gas is collected with a pressure of 735. So that's the whole gas. The whole gas is 735. Nitrogen's gas is 382. What's the pressure of hydrogen? So it's just a subtraction. When we subtract 382 from 735, we get 353. So that is your partial pressure of hydrogen. And that's it for Unit 11. Yay!